Hello again. We're working with the law of sines, and this is a no solution case that we're going to be working with, where a equals 50, a equals 5, and b equals 9. And I mean, I can tell really quickly because, you know, if you take the sine of a sine of 50 times 9, it should be less than this. But if this is less than this, it kind of works out the other way. Sine of that, I don't know what that is off the top of my head, but I know that this is going to be more than this. That's all I really know. I know this is, I don't know, slightly more than 0.707. Anyways, and I know that that's still going to produce a bigger answer. So I know that's a no solution case, but I try explaining that, and it doesn't, you know, really fall in line. Then I kind of draw an example. And that doesn't really fall in line with students too. It is a difficult concept to understand. So what I do is I show students this. I say, you know what, let's just try a problem. Let's see how it goes. And then I say, do you know C or angle C or C? No, so don't worry about that yet. We're going to try to figure out angle B. And I say, okay, let's just draw a triangle. You know, let's just kind of hope that it works. So I've got this triangle, ABC, where A is 5, B is 9, and I don't know what C is, but I know that this is 50 degrees. So I'm going to go ahead and I'm going to try to figure this out. And I'm trying to tell students that it doesn't work, these parameters don't work for the law of sines. It's just not going to work. So we go ahead and we do this example, and I say, okay, let's use sine of A over A. So it's the sine of 50 degrees over 5. Equals sine of B, which I don't happen to know off the top of my head. Nobody is going to either because you're not going to figure it out. Over B, which is 9. What I'm going to do is I'm going to go ahead and I'm going to cross multiply. And I'm going to go ahead and show every step here because it's not going to take that long. Sine of 50 degrees times 9 equals sine of B times 5. So the sine of 50 degrees, why not go ahead and try it, is 0.76604 something times 9. I'm going to round to the 6.89. Yeah, 6.89 is fine enough for me. So this is 6.89. Now like I said, these two when you multiply them shouldn't be greater than 5, and 6.89 is greater than 5. It's going to cause a stir, and here's what I mean. Equals sine of B times 5. What you want to do is you want to get the B by itself, the angle B. But in order to do that, the first thing you have to do is divide by 5. Divide by 5. That presents a problem. Divided by 5 is approximately 1.38. Something like that. It's approximately. I went ahead and I took the long answer and I divided by 5 and I rounded to 1.38. Equals sine of B. What I want to do in order to get the B by itself is take the inverse sine of both sides. It's not the reciprocal, it's the inverse. What I do on one side, do on the other. And what you're going to get when you go ahead and do this, second sine of 1.38 is domain error. And there's actually a very simple reason why that's the case. It's not going to exist. And the reason is, when you're working with a sine curve, a sine graph, or even when you're working with sine values, they go from -1 to 1. -1 to 1. That's the restriction that you have. When you plug in values for your you know, if you plug in angle values for your sine, your y values are going to go from -1 to 1, unless you got a different amplitude, and unless you got a value that's being multiplied in front of the sine, which we're not actually even doing in the first place. So 1.38 is too big a value to even plug in. It should be from -1 to 1. It can't be bigger than 1, and it can't be smaller than -1. It's already a domain error. So that's a problem. You know, you got sine of 50 degrees and 5, and then you got this side equaling 9. If I drew this actually as perfectly as I wanted to, this triangle wouldn't connect. There's absolutely no way that this triangle can connect given these parameters. But when I say that, students say, oh, you know, I can't really kind of visualize that. Even when you show me, it doesn't make sense. And I say, okay, the best way to memorize it is this. If you've got something like this, where it's greater than 1 or less than -1, and you're taking the inverse of that, you know it's going to be a domain error. It just can't possibly work. So that's an example with no solution. And that's what happens when you use the law of sines, where you're given an angle, its side, and a different side. You know, it's really easy when you're given two angles. You're not going to have that problem because you're going to figure out the third angle and you've already given the side. That's fine. When it's obtuse, it's really easy to just determine by a picture. But when it's acute, it's very difficult, and you got to make sure that you go ahead and do that. We're going to do a case, we're going to do an ambiguous case next actually, where we're going to work with two different solutions. And students don't always like that, but I think it's pretty informative. Hopefully you found that informative or helpful for the most part. With that said, have a good day, friend.